Hello everyone, welcome back to the channel Microbial World. In this video, we will be discussing a general introduction about light microscope. So before we go into the topic, we need to know how the microscopes were discovered, that is, the history of microscopy. There were two Dutch scientists named Zacharias Janssen and his father Hans who made spectacles. They discovered a very simple microscope. What they did is that they experimented with lenses. They combined the lenses in a tube and observed that the objects that were nearby appeared closer and larger. But this was not included as a scientific discovery. So, when we look into the history of microbiology, it was Antony van Leeuwenhoek who made the first simple microscope. Now, Antony van Leeuwenhoek, he is known as the father of microbiology. He is also the father of microscopy, and he is a Dutch microbiologist. So, using his microscope, he observed the presence of tiny living organisms in pond water, and these organisms they appeared like dots. So, these organisms they were bacteria, protozoa, which he referred as animalcules. He called them as animalcules. So first he observed protozoa and several years later he observed bacteria. Now his microscope, it was made of a double convex glass lens held between two silver plates. What we need to understand is that the application of microscopy has enhanced the visualization of cells and microorganisms by magnifying their images. So what are light microscopes? It is a biology laboratory instrument or tool that uses visible light to detect and magnify very small objects. Now this visible light, the range of wavelength of visible light is 400 to 700 nanometer. So these microscopes, they use lenses to focus light on the specimen, magnify it and produce an image. So this magnification, it can vary depending upon the type and number of lenses that make up a microscope. So every time we are seeing the microscope, it will magnify the specimen or it will magnify the object. So what is exactly magnification? Magnification means the microscope, it will enlarge or it will increase the size of that specimen or it will enlarge or increase the size of that small organism or object. Depending upon the number of lenses, there are two types of microscopes. That is simple light microscope and compound light microscope. Now the simple light microscope, it has a single lens. So as it has only a single lens, this microscope will have low magnification. Whereas a compound light microscope, it is having at least two lenses, an eyepiece and an objective lens. So these microscopes, it will be having higher magnification when compared to that of simple light microscope. Functioning of a light microscope. So you can see here, there is a light source, condenser lens, specimen that is placed on the stage of the microscope, objective lens, and this is the image. So the specimens, it will be very small and transparent. So what the lens do, they will focus the light through the specimen. The image will then pass through one or two lenses for magnification for viewing. Now the transparency of the specimen. The transparency of the specimen, it will allow easy and quick penetration of the light. The specimens, it can vary from bacterial to cells and other microbial particles. Principle of a light microscope, or we could say optical microscope, because these light microscopes, they are also called as optical microscopes. Now these light microscopes, it is working by the principle of refraction. You have heard this term from your physics class, right? So what is refraction? It is the bending of light as the light passes from one medium such as air into another medium such as glass or water of different optical density. Why does the light bend? It is because the speed of the light changes when the light crosses the boundary between two mediums. You can see here, if consider that the light is passing from a less dense medium like air to a denser medium like glass. So at that time, the speed of the light, it will decrease and the light will bend towards the normal. It is an imaginary line perpendicular to the surface. So this is the incident ray and this is the refracted ray, and you can see here the light has bent towards the normal. Or if the light is passing from a denser medium like glass to a less dense medium like air, so at that time the speed of the light increases and the light will bend away from the normal. The bending of light, it is determined by refractive index. Refractive index, it is denoted by N. Now this refractive index, it is a measure of how much a substance will slow the speed of light. Now just consider that an object, it is placed between two mediums such as water and air. Now if that object, it is a prism, when the light passes through it, what the prism does is that the prism, it will bend the light at an angle. So this is the same way that microscopic lenses also work. The lens, it will bend the light at an angle. So the convex lens, when they receive all the light rays, what they do, they are focusing all those light rays to a point that is known as the focal point or F point. And the measure of distance from the center of the lens to the focal point is called the focal length. Now, a strength of the lens, it is determined by the focal length. If a lens, it is having short focal length, then it can magnify the objects more when compared to that of a lens with long focal length. So there is another important term that is associated with a microscope, that is resolution. Now see, you can see here there are two objects. It is separated by a very small distance. Now, if the microscope is having ability to distinguish these two objects that is separated by a small distance, then that microscope is said to have a high resolution. Whereas, if the microscope, it can only distinguish two objects that is separated by large distance, then that microscope is having a low resolution. So we can say the resolution as minimum distance between two points that is distinguished by the microscope. So if a microscope, it is having higher resolution, then even the smaller details of that specimen can be observed. The resolution, it is determined by factors such as wavelength of the light and numerical aperture. So different types of microscopes such as optical microscope, scanning probe microscope, electron microscopes, they are having different resolution capabilities. So there is a formula associated with resolution, that is 0.61 lambda by numerical aperture. So this lambda, it is wavelength of light. Now let's see what is numerical aperture. So numerical aperture means it is the ability of the microscope to gather light and resolve fine details of the object. So the numerical aperture, it is equal to n sin alpha. N means it is the refractive index of the medium between microscope's objective lens and specimen, and alpha, as you can see here, it is the half angle of maximum cone of light that can enter the objective lens, or we could say it is the angular aperture of objective lens. Angular aperture of objective lens. So now for microscope, it is having high numerical aperture. That means the microscope will gather more light, it will resolve the fine details, thus resulting in improved image clarity and resolution. Improved image clarity and resolution. Types of light microscope. So there is bright field light microscope, dark field light microscope, phase contrast light microscope, and fluorescence light microscope. So these are the different types of light microscope. We will be discussing each type of light microscope in detail in the upcoming videos. Keep watching my channel for more informative videos. Thank you.